So welcome everyone to this session on learning Kubernetes through AKS. So AKS is Azure Kubernetes Services. Think of it like any other Kubernetes running on Azure. Now, in a typical cloud context, what we really understand by any workload is some sort of virtual machine running, and on top of that, you have the software installed and configured in that cluster, which will serve you the purpose of that application. So in the context of Kubernetes, we can assume that we have got a few set of virtual machines, which we are leveraging at the end of the day. And then there is the Kubernetes runtime, which is installed in those virtual machines and configured as a cluster. Now, what we essentially use in the Kubernetes world is set up APIs to interact with. So the API is sitting here in the software version, which we will be leveraging. Now, if you look into the Kubernetes, it basically has got set up building blocks. So we have pods, which basically host your um, container, and then you have your deployment and services. Now, imagine that you have a web application which is in a container already created and ready. So this is your image, that's container image sitting somewhere in the container registry. Either it could be a public, private, whatever that registry suits you. Now, when you have that, you create a pod and it gets deployed. Now, how do you really create a pod in Kubernetes? You need to use this API, and you can use many different tools. kubectl is one such tool, which essentially uh, gives an ability to have an HTTP call to this API and then does things for you. Now imagine that you go in a declarative way, which means that you define an YAML file, which is set of instruction, and then you call that YAML file through this kubectl. So your typical command may look like kubectl and apply and the file name. And that basically is going to go ahead and create a set of pods in the Kubernetes. So it can land, all of them can land in the VM1, or they can get distributed to all the three virtual machines behind the scene. Now, what happens? You don't create the pod directly in the Kubernetes, but you create something called a deployment, which is a self-healing mechanism, so which keeps track of the pods which is behind the scene and check the health of the pod. So that's a way to define a reliable deployment. So reliable application deployment. So one given point in time, one pod may go down, there will be immediately another pod replacing that pod. So you will always have a healthy three pod running behind the scene. Now, what happens that you expose this deployment or all this pod via an HTTP endpoint that is called service. So service is sort of like a load balancer in Kubernetes. It's a native to Kubernetes. It either helps you connect from another service, let's say S2, and then you can connect it, or you can connect it from outside. Now, when you want to connect it from outside, if it is especially in the cloud, right, then you can use the cloud load balancer, which is having a public IP address. And then it can actually point to this service, which is a Kubernetes thing. So for an end user who is connecting your service, directly point to that public IP address of the cloud load balancer, which is basically being provided by the cloud vendor. It can be Azure, AWS, uh, or Google Cloud, or anything which Kubernetes will take care through its cloud controller manager. And then the public IP address will be available with a DNS mapping to the end user, and end user doesn't need to know how the big things are happening. So at any given point in time, if you want to increase the capacity to 4, 5, and so on and so forth, you don't really need to worry too much from an end user perspective because you are anyways pointing to this public IP. This service will create endpoints to these individual pods getting created or deleted automatically. So that thing happens constantly behind the scenes. So you don't really need to know about the individual IP addresses, though each pod gets an IP address allocated by the Kubernetes through its pod networking capability. But these are all irrelevant to the end user. It is relevant to this service because this service needs to create the endpoint mapping to this individual IP addresses and the port being used for this container image. So that happens behind the scene and gets updated whenever there is a change, a pod getting replaced from a 1 to 2, if that movement happens, if this goes down and if upgrade is happening. So this thing can happen. So pod can get shifted from one actual virtual machine to another actual virtual machine. If that is the case, the IP address may change and the service will remap that with a new endpoint, but this will remain the same. So you land here, it'll be redirected to one of that distributed container. So your application should be written like a distributed application. So there should not be any dependency, local dependency within the pod. Now let's see how that really works in actual scenario. So what I'm going to do is that I'm going to go ahead and use my console. So you can use any. So I'm using my Windows subsystem for Linux, so which is running Ubuntu 20.0, and I have my Kubernetes up and running in this. So let me show you how that looks like in the visuals representation. So if I go into my resource group, I have a Kubernetes cluster created. Now what I am going to do is that I'm going to point to this Kubernetes cluster and I'm going to first log into this Azure portal from my console. So let me say AZ login. If I do so, then because I'm using Windows 11, it will ask me to log in to the Azure portal. So I will just provide the same username and password, and I'll be pointed to this. Okay, so let me use this other term, use device code. So if you use this, use device code. Now you can log into any browser anywhere, not just in this machine. Just provide the device code while you log in, then it will help you point to that. So this is the URL you need to log into. So let me click on that, or you can copy this and open it in here. Okay, let me go back. Microsoft.com device login, maybe I can type it. So this is the basic step you need to take to do that. Now it is kind of ready. Now what I need to do is that I need to copy the device code, which is here. That is this one, and then come back over here and paste it. Once I paste the right device code, which is being used here, and then give the login credential, which I need to log into, I can do it anywhere. So I can just do it in this machine, or I just need to do it. So there's a multi-factor. So let me just accept that multi-factor and proceed further. Give me a quick moment. And I just provide that. And here you go. So I am kind of logged in to this, and it says continue. And you should be able to see in the console where I have tried to log in, it is going to display the services or the subscriptions I have access to. So I am now in this console logged into my Azure subscription. So this is going to happen in a moment. Once this is accepted, what I'm going to do is that I'm going to point to this Kubernetes cluster, which is already created. So Kubernetes cluster is generally takes some time to create in Azure. So what I have done this pre-creation process. So let me show you the details here. If you see here in the portal, it gives you a little help, which is basically how you get the credential locally downloaded. Now I'm going to use this kubectl. Now you can see that list here. I'm going to use this kubectl. So if I do that, then it gets downloaded into this local machine, into my local desktop. So I'm right now pointing my kubectl to this Kubernetes cluster. Now, if I just go ahead and create an alias so that going forward, I don't need to CTL, so it has to be right. If I say K, and then it shows the kubectl. So it is equivalent to you typing kubectl. So if you do that, the kubectl is kind of reduced to K, which is helpful for me to type quickly. Now, if I say K get nodes, just to make sure that I'm pointing to the right set of nodes, this will give me the list of nodes. Now, we'll go back to our diagram, which we try to draw over here, where we kind of try to create set of pods. So what I'm going to do now, I'm going to just go ahead and say that, let's see this one. Now, if I try to make it simple, what I'm going to do is that I'm going to go ahead first show you how you can create a pod. Okay. And we'll use any standard image so that we don't need to build that image by ourselves. So there are so many images we can use. So I'm going to use Nginx, which is one of the easily available images, which is basically a simple web server. So Nginx is a image which will run as a container inside my pod. That's the first thing I'm going to do. So that's the basic step. So let me do that. Now it is pointing to the right AKS cluster, which is why I just wanted to test it. Now, if I say K run pod 1, that's the name of the pod, and I say image Nginx. So it will pick up the image from the Google image registry and get me an Nginx pod created. So if I say K get pods or PO, you will see that the list of pods running now in my local machine. And one of them is the pod one, that is the Nginx. To know more about that pod, you can say K describe pod 1. And if you say so, then it will talk about this image is Nginx and it is successfully pulled. This is the event which is captured. So the pod is running. But this pod is not accessible to anybody outside of this cluster. Now we will make it. Now, one of the things we talked about while we designed the diagram, like we need a scalability. So at any given point in time, this is a web application we are running, right? So we want to distribute this web application and scale it. So we want to create, let's say, pod 1, pod 2, pod 3, pod 4, right? And also maintain them. So if we want to do that, we can't really keep creating pod one by one. So what we want to do is that we want to create a deployment, and then behind the scene, this will create a pod. So how that will happen? So that can happen using a deployment. So let's create a deployment. Now you remember that we get kget pod, we see 2 pods. Now I'm going to create a deployment. Now this time I'll say k create deployment, and then I need just use this name called web, and I say image equal to nginx. If I say so, then I have created setup pods, okay? Because I did not mention any size, you will see only one pod, but the name of the pod will have some random name alongside with the web. So it'll be web dash something. So let's see how that looks like. So I'll say kget pod. You'll see the list of pod and one of them is web. That's coming from the deployment. And you can see that it's just now created 20 seconds ago. So what I can do now, I can get inside that and modify this deployment. I haven't yet used the YAML because that becomes a little more advanced. Going forward, we will be using YAML, but we'll see how we can scale this deployment. So one of the ways is to kedit deploy, and the name of the deployment is web. And that opens the deployment definition in an YAML file in front of me in the editor. And then one of the things I can change here is the replica set. So if I say that I want to have 3 replicas instead of 1, and you will see that total 5 pods will be in the list. So once this edit is accepted from the console perspective, the API sends me a message back saying that the deployment is edited or modified. And then I can run this command called kget pod, and you will see that total 5 pods running in that local. So 3 of them having web dash as the name with some random number is coming from the deployment. So we are now able to create a deployment, which is a self-healing mechanism. One of the things I wanted to show you is that if I go ahead and let's say delete this, say k delete pod and the pod number, pod name, what it's going to do is that it's going to go ahead and kill the pod, and the list of pod will never show this MySQL anymore. So MySQL pod is gone, right? So it's saying container creating. It's going to go ahead and delete that. So let me also delete this one. I say delete pod, then pod 1. So I will not have any pod except the fact I have only 3 pod running in my current cluster within this namespace at this point in time. So you will see that you will have only 3 pod running, and then things will get deleted once this thing is sort of like my. So you can see that MySQL is coming from a deployment, so it's saying container creating. So let's see what all deployments you have. So if you say deploy, you will find the deployment get deploy. You'll find the list of deployments. So I'm gonna go ahead and uh, delete the deployment. Um, so we'll stay here, but once we basically can delete the deployment, all the pods will be deleted. Now we have 3 pods because we said the replica 3, so they are all running fine. That's all right. Now what I'm gonna do is that I'm gonna go ahead and let's say build a service which will allow me to interact with this. Now, eventually at this point in time, I'm not inside the cluster. I am connecting the cluster from my local desktop laptop. So I can't really reach out to this pod because they each will have an IP address. So if you see the details of the pod, right? Uh, if you say get pod wide, that will give you a bit more details. Now you can see that they all have IP addresses. So IP addresses are very local to that. So if I'm part of this network, the cluster network, and if I have a VM where I can log in, I will be able to point to that pod because they are local to this cluster. But outside of the cluster, I'm not able to access. Now, what is the way to access it? The way to access is through service. Now we talked about it, right? So we need a load balancer, sort of like a service. Now what we have behind the scene is a deployment, which is basically managing all the pods. So this is what we call a deployment in Kubernetes. So you have this deployment running. And then now what I'm going to create is I'm going to create a service. The service is something which is sitting on top of the deployment, pointing to the deployment. So this is very loosely coupled thing, which means that even if you, let's say, delete a deployment, a service still exists. It is just a pointer, okay? So pointing to a deployment. It's not a physical resource which gets created. So it's sort of like an entry in the system, okay? So that's what services does. Now, as I said, that you can define a service in many different ways. It can be a local cluster IP, or it can be a node port, or it can be a load balancer. So if you choose the load balancer in a cloud scenario, what the Kubernetes will do, it will trigger request the cloud provider to create a load balancer. Now the cloud load balancer will come into the picture, and then it will have an IP address which people will point to, which will basically be pointing to your service, which eventually will point to this deployment. So that's how the sequence looks like. Now let's see how that can happen in the console scenario. So if I go back here and see how we can create this, so let me increase the size, and then I say this gone. Now let me say what all services I have today in this. So we have got services like SQL headless, Kubernetes. That's fine. So we don't really bother about that. But let's go ahead and create a service for the deployment. So we can do it through YAML, but we can also do it through kubectl. So if we do that, now we use something called kexpose deploy web, because we are going to expose this deployment as a service, right? So, and then I need to say, what is the port? I'm going to use this port 80. So that's what I'm going to expose this. So if you see that previous command where I was trying to see what all services I have, I will now have the service for my web, which is created right now against the deployment called web. Okay. So we are pointing to the deployment. So you can see that the web service is created with a type called cluster IP, having an IP address which is again an internal IP address to the cluster, and using exposing the port 80 because I'm using Nginx website, which requires to expose the port 80. So that's fine. That's still fine. Now I want to modify that to a load balancer type of thing. Now you can see that this doesn't have an external IP address, so I will not be able to access this from my browser, from this machine. So if I, let's say, try to do a curl to this, it won't work. So if I say curl and then HTTP colon and this IP address, nothing gonna happen because I won't be able to connect to this because I'm not part of the network yet. So what I need is a public IP address to reach out to this service, which basically will serve me Nginx. Okay, so that's not going to work. So it'll keep trying, but it's not going to work. So let's see how we can edit this service again. So kubectl edit svc web. That's the name of the service I'm going to edit. Now, when I say edit, now one of the things I can say that type, and then this needs to be load balancer. If you say so, and then come out of that, what happens is the service is edited. Now, if I get to see the list of services which is now available, I will see that the external IP is pending. Now we can go in a watch mode, and I will see eventually the cloud will create its cloud load balancer, and that IP address will be given to me. So this is the IP address you can see got generated from the cloud. So if I take this IP address and then do a curl here, and I say HTTP colon slash slash this because I'm using port 80, now the Nginx page is coming up. Now, in fact, I can go to this website and then run this IP address. So if I run this IP address, you can see that this is directly coming from my AKS cluster which is running within the Azure, and then but I'm able to view that page. So that page is kind of visible to me right at this point in time. What I wanted to also do is now increase the instance count from 3 to 4. If I do that, this IP address never changes. For an end user, it doesn't really matter. That's the beauty here, right? So if I, let's say, go back into my console, which is this one, and I say kedit deploy web, and then I see the web here, and instead of replicas 3, now the holiday season is coming up, so we need more capacity to entertain that. Now it's gonna go ahead and have 4 pods. So if you say this, you'll find 4 pods now working for the web, and that means that you're gonna go ahead and uh, get 4 IP addresses. Now, to see what the IP address really means here, if I say kget svc, you have the list of services here. And if I say kget svc web, you will see the details about this service, right? So this is the service I'm talking about. And if I say k describe, and you will see the description of this, whether we'll be able to see the endpoint. So you can see dot dot more, which means that these are all endpoint. If you want to see like k get svc and output it to YAML, if you do that, now let's see the YAML output. And you can see that it basically is how that gets created, right? But at the end of the day, this contains setup endpoints. So if you see that kget describe SBC web pointing to the one which will have endpoint. These are all IP addresses of your pods using the port. That's a combination. So if you call that the service, if you land to this service, it'll call one of these endpoints. Okay, so that's the kind of thing which happens behind the scene. And you can see that it says that load balancer, which uses the cloud load balancer. So you can see that it's an ingress controller, and it is having a public IP address, this one. And this is accessible from anywhere you want to connect to that. So you basically have built, what you have done is that if you go back to the diagram, you have built an application, web application, pointing to this service. So people are using a public IP address to um, reach to this service. Okay, and then they are landing to this deployment pointing to one of these spots. So you basically have this ability to really build something up. So you can see that we are kind of doing this exercise over here to make sure that different building blocks together build a complete end-to-end reliable solution, which is hosting this Nginx website from an image. So that image is built, that image is created, but now we are taking the Kubernetes power to deploy something which is highly reliable and available. With this, thank you very much and have a wonderful day.